All right, this is the first video in a sequence of videos working through problems from Sheldon Ross's First Course in Probability. It is one of the gold standards of probability, so if you're teaching yourself or preparing for an exam or taking a course, this is a great book to give you lots and lots and lots of practice problems. So I feel like that's the way to learn anything, is to work through problems. Okay, so these are the first four problems in his 8th edition, which they're pretty standard from edition to edition. But we're going to look through these four, practicing our different techniques, and then later videos will work later problems. All right, so starting with number 1, how many different 7-place license plates are possible if the first 2 places are for letters and the other 5 for numbers? Okay, well, I like to make my slots to represent the letters that we're going to have, and that each slot represents the first step or a step in the process. Okay, so the first 2 slots are going to be letters, and here we have no restriction on repeats, so we are presumably can use any letter over and over and over again. So our first slot, we have 26 choices for a letter, and we have 26 choices for the next letter as well. The last 5 are to be digits, and we have 10 digits to choose from. We can repeat any of them, so we have 10 choices for the remaining 5 slots. So multiplying those all together gives you the total number of license plates. All right, for part B, it's the same question, but this time we don't allow for repeats. So our first slot, we have 26 choices because we haven't used any of our letters yet. And then the next one, we only have 25. So once we've used up a letter, we only have 25 left. A similar process goes for the 5 numbers at the end. We have 10 choices, then we have 9, 8, 7, and 6. So this is a lot less in the second case when we don't allow for repeats. Both of these involve order, so the order matters. In the first one, repeats are allowed, and the second one, repeats are not allowed. So those are 2 of our common counting problems. Often what you want to think about is, does order matter, and are repeats allowed? All right, let's look at this next one. How many outcome sequences are possible when a die is rolled 4 times, where we say, for instance, that outcome 3, 4, 3, 1 is the first, then the second, then the third, and the fourth. So the words here that they're leading us to is that we have an ordering to our rolls. So it's not just that there are 4 dice on the floor that we're reading. There's a first roll, a second roll, a third roll, and a fourth. So order does matter here. And since a die can be anything on any roll, repeats are allowed. All right, so we have 4 slots because we're rolling the die 4 times, and in each slot we have 6 choices for each roll. 6 times 6 times 6 times 6, or 6 to the 4th. Okay, straightforward. This next one, 20 workers are to be assigned to 20 different jobs. Again, look for your keywords as you're reading, 20 different jobs. So that's imposing an order. That is, one job, perhaps cleaning the floors, is very different than cleaning the windows. How many different assignments are possible? So we're going to place, let's keep our colors consistent. We're going to place our 20 jobs in a line, or we could even, for that matter, place 20 workers in a line and assign each worker a job, or assign each job a worker. In any case, we're going to take, we have 20 choices for the first, so let's just say these are our workers here, worker 1, 2, 3, and down to 20. The first guy has 20 choices for the job, and then after that, 19, 18, and so on down to 1. So when we have n objects and we arrange all n of them, that's a permutation of n things, and we know that to be n factorial. So here, this is 20 factorial. All right, last one for this video. John, Jim, Jay, and Jack have formed a band consisting of 4 instruments. If each of the boys can play all 4 instruments, how many different arrangements are possible? So what we're really saying here is that, well, let's line them up. So let's, first of all, we can line up our order that's imposed, and that's by the names of these people, right? So our order is really the assignment to a particular person. So if they can all play any of the instruments, and presumably they each only play one and everybody plays one, then John has 4 choices at the beginning. Once he's picked an instrument, then Jim, he has 3, then Jay has 2, and Jack is left with the last one. So this first question is 4 times 3 times 2 times 1, or 4 factorial. All right, B, which it really says B, but we can read it as B. What if John and Jim can play all 4 instruments, but Jay and Jack can each play only piano and drums? So I'm just going to reorder these just for my sake of counting. So Jay and Jack, so again we're assuming that all instruments are played and everybody plays just one. So this first restriction is imposed on Jay and Jack. So Jay and Jack can only play piano or drums. So a way to think of this is that Jay has 2 choices. Jay has 2 choices, in either piano or drums. Once he's selected, let's say, piano, then now Jack only has 1 choice. Now, even though John and Jim can play any of the instruments, they're restricted by what Jay and Jack can play. So really, John and Jim can only play the other 2 instruments. All right, so even though Jay and Jack are the ones that can only play 2, it forces John and Jim to only be able to play the other 2. So of the remaining 2, John has 2 to choose from, and then Jim has only 1 to choose from. So in this case, it's 2 squared. All right, that's it for the first 4. Tune in to see the next few. And remember to go practice.